Hello everyone, welcome to my course on Digital Design ECE 275. Digital systems are used extensively in computation, data processing, control systems, communications and measurement. Because digital systems are capable of greater accuracy and reliability than analog systems, many tasks which were formerly done by analog systems are now being performed digitally. So before going into digital systems, we must first understand what a signal is. So a signal is a variation in a physical parameter with respect to time. For example, temperature variation is a signal. Sound is a signal. Video is a signal. Well, video is nothing but light intensity variation. So all these signals may need to be stored, processed, etc. For example, take a microphone. The speech signal that is given to the microphone, it might need to be amplified and given out of the speaker. We are in the electrical and electronics engineering domain, and hence we talk about electrical signals. Therefore, a signal in this domain is known as an electrical signal, which is nothing but the variation of an electrical quantity like voltage or current with respect to time. So when we deal with analog signals like temperature, humidity, seismic activity, sound, etc., we need to convert them into electrical signals. This is done using sensors. So sensors basically convert non-electrical parameters to electrical parameters like voltage or current. So basically a sensor, it comprises of transducers plus some additional processing. Normally, an analog signal can take any value, that is within a given limit at different instances of time. So this is how an analog signal looks like. On my x-axis, I have time, and on my y-axis, I have amplitude. So my amplitude goes from 0 to A max. It can be negative as well, but let's just deal with the simplest case where the amplitude goes from 0 to A max. And my analog signal can look something like this. So as you can see, the signal is continuous over time and it can take any value between 0 and A max. So this is an analog signal. Now suppose you want to process a signal at discrete intervals of time. So for example, I want to monitor the temperature of a processor every second or every minute or an hour or a day. So the temperature is varying continuously, but you are only looking at it at specific time intervals. Such a signal is known as a discrete time signal. Okay, so assuming that this was the temperature variation over a period of time, now what I'm going to do is, I'm only going to consider values at discrete intervals of time. So let's say T1 is at R1, T2 is at R2, T3 is at R3, T4 is at R4, T5 is at R5. So I'm monitoring the value of temperature over 5 hours with an interval of 1 hour. So this is known as a discrete time signal. So as you can see, I'm not too worried about what happens in between. For example, between T1 and T2, I'm not worried about how it's varying. I'm only worried about how it's varying at time, what's the value at time T1 and what's the value at time T2. So this is the difference between an analog signal and a discrete time signal.